So, good day to everyone. So, hello. Okay, there you go. Hello, hello. Sorry. So, good day to everyone. So, for the part 3 ng ating topic about the stoichiometry and concentration of solutions. So, magpo-focus naman tayo ngayon dun sa mga concentration of solutions, uh, stoichiometry related to the solution, especially yung when it comes to the formation of precipitation and as well the titration, okay, in the cases of acids and bases, no? So, ngayon, simulan natin, no? Of course, pag sinabi nating solution, it is an homogeneous mixture which comprises of two substances. We have the solute and the solvent. So, on how we are going to form the solution, it is made by dissolving the solute in a solvent. Basically, yung solute, it is the substance that is being dissolved, and the solvent, it is a medium in which the solute is being dissolved. So, once the solute is being added to the solvent, so the particles of the solute will distributed evenly, okay, to form a solution or evenly mixed. Ayan. So, ayan po yan. Now, we have some classifications uh, according to the uh, different parameters. So, we have the types of solutions based on the solubility. So, ano ba yung pag sinabi nating solubility? Basically, when you say solubility, it refers to the maximum amount of solute that will dissolve, okay, in a given quantity of solvent. Yan. So, kumbaga, dito natin malalaman kung gaano karaming solute dapat ang pwede nating ilagay in order to maximize. Ayan. So, we have the following. We have the unsaturated solution. Dito, ang nangyayari naman dito is hindi pa niya na-reach yung maximum amount ng solute na kailangan, kaya marami pang solute ang pwede pang ma-dissolve. Pag saturated solution, so dito naman, na-reach na niya yung maximum amount, okay, ng solute na kailangan. So, therefore, there will be no more solute that is going to dissolve. So, kumbaga, yung mga susunod na solute na is magiging, parang the same lang. So, hindi lang siya ma-dissolve. And then, pag supersaturated solution, in which, na ang nangyayari na dito is nagiging unstable na po yung solution, and at the same time, ay nakakabuo na po ng mga crystals. So, kumbaga, parang parang nagpapatong-patong na lang po yung mga solute na hindi naman po na-dissolve. And from this, habang tumataas yung saturation ng solution, ay tumataas din ang kanyang concentration level. Ayan po yan. Now, we have this based on the amount of solute or the amount of solvent, no? Dito naman, kapag mas marami yung amount ng solvent compared dun sa amount ng solute, so dito po pumapasok yung tinatawag na, ayan, kung napapansin nyo sa ating picture, sa ating image, ay maraming solvent, diluted po yan. Kapag naman po mas sabihin natin equal or even distributed naman yung amount ng solute at ng solvent, or mas higit yung amount ng solvent, ay nagiging concentrated, amount ng solute ay nagiging concentrated ang solution. So, ayan naman po yan. And then another one is based on the electrical conductivity. So, kapag sinabi natin electrolyte solution, so, ito po yung kapag na-dissolve natin yung ions o yung, let's say, yung isang ionic compound na hinalo mo sa isang solvent, ay may nabubuo po mga dissolved ions. Ayan. So, nade-dissolve po siya into ions. Kapag naman nade-dissolve po siya into molecules, ang tawag natin din sa solution na yon ay non-electrolyte solution. Usually, pag mga electrolyte, ang mga solute natin dito ay yung mga ionic compounds. Tapos, dito naman sa may non-electrolyte, yung mga covalent compounds. And kasi, they are just sharing electrons. Ayan. And usually, ito yung mga non-metals. So, that's why, ang nabubuo pong mga particles lang po sa kanya ay mga dissolved molecules. Ayan. Okay. So, we have this concentrations of solution. So, dito natin aalamin on how we are going to express the concentration of solution base po doon sa given amount ng solvent, given amount ng solute, at o di kaya given amount ng solution. So let's start with the first one. We have the percent weight of solute, which is based lang naman po yan sa mass of solute, then divide lang natin sa mass of solution. And then percent volume naman, nabase naman sa volume ng solute at volume ng solution. So, ayan po yan. Percent weight, pwede rin natin siyang tawagin percent mass. No? Okay. Now, let's have this, another one. We have the mole fraction. So, dito naman sa ating mole fraction, so basically, it refers to the number of moles of solute as a proportion of the total number of moles in a solution. So, kumbaga, dito, inaalam lang natin yung percentage ng solute or ng solvent in terms of number of moles. So, let's say we have this two components. We have A and B. So, pwedeng yung A is the solute at saka yung B ang solvent o di kaya vice versa. So, para makuha natin yung mole fraction ng A and B, so what we're going to do is to identify yung kanilang number of moles. Kung hindi po identified, let's say in terms of mass pa yan, so kailangan yung mass, i-divide mo sa molar mass para makuha mo yung number of moles. So kapag halimbawa, hanapin natin ay mole fraction ng A, so mole of A, i-divide lang natin sa sum ng moles ng A and B. Then para naman sa mole of B, okay, mole of solute B, so or para sa mole fraction ng B, so mole of solute B divided by the sum of solutes A, sum of the moles of the solutes A and of A and B. Ayan. Okay? And then dapat kapag pinagsama natin yung kanilang mole fraction summation, that will be equivalent to 1. Ayan. Now let's go to the molarity. Ayan. So number of moles of solute dissolved in 1 liter of solution. So dito naman natin nalalaman yung concentration ng solution base po sa magiging amount ng solute, okay, versus the liter of solution. So take note, nabanggit natin kanina, we have the concentrated and we have the diluted solution. Ayan. So molarity can be calculated by dividing the mole of solute, kung ilang moles ng solute ang meron, divided by the liters of solution. Okay? Ayan. So, for example, basically, ang unit naman niya is molar or moles per liter. So, if we say 3M or 3 molar, that is 3 moles per liter. 3 moles of solute per liter of solution po yan. Okay? So, yan po yung pagdating sa molarity. Let's have the molality. Molality, it measures the mole of solute being mixed in the kilogram solvent. Po yan, no? Pag sinabi naman natin molality. Yan. So, being dissolved in 1 kilogram of solvent. So, the unit there is 3 molal or 3M. That is being equivalent to 3 mole of solute per kilogram of solvent. Okay. Then, let's have the normality, which is equivalent to the number of moles. It should be number of moles number of gram equivalent weight of solute per liter. Yan. So, yan naman po yung pagdating naman sa normality. Okay. Basically, makukuha lang natin yung normality or masasabi lang natin na ang solution is normal kapag meron po siyang gram equivalent weight na base po sa acid at sa base through their ions. So, sa acid, we have this hydrogen ion, and dito naman we have the hydroxide ion. No? Correction lang po, no? It should be gram equivalent mole. So, hindi po pala weight. So, it should be gram equivalent mole. So, medyo baguhin lang natin yung definition lang po ng nito. So, it should be mole. Yan. Okay? So, yan po yan. Medyo binago ko lang po yung definition. And then, sa base nga po, we have this hydroxide ion. So, ngayon, alamin natin, no? Okay. Paano ba kumuha ng equivalent weight? So, para po makuha yung equivalent weight, let's say we have the molar mass of sulfuric acid. O, gamitin natin yung sulfuric acid. Alamin natin yung kanyang equivalent weight. Okay. Para dun sa kanyang normality. So, sa molar mass niya na meron siyang 98.086 grams per mole, okay? So, para makuha natin yung equivalent weight, so i-divide lang po natin yung 98.086 sa number of hydrogen or hydroxide ion. At dahil ito po ay acid, so kukunin natin yung number of hydrogen ions na meron siya. So, malalaman natin yan sa pamamagitan ng kanyang subscript. Kaya itong 98.086, i-divide lang natin yan sa 2. Okay, so you will get 49.043 grams per mole. So that is how you are going to compute the equivalent weight of acid or base. Depende po sa number of ions or hydrogen or hydroxide ions. So we have this relationship between the molarity and the normality. So the normality is equivalent to n, which is an integer. So actually it dictates the number of hydrogen ion in an acid or the number of hydroxide ion in a base being multiplied by the molarity. So, kumbaga, pwede natin dito malaman, no? Kapag may given na normality, malalaman mo na kung anong kanyang molarity. Ganun din, pag molarity, papuntang normality. So, if you have 3M, okay, of sulfuric acid, no, yung kanyang molarity is 3 molar per liter, mole per liter. So, meron din yang 6 mole per liter bilang normality naman. So, kumbaga, ang ginawa mo lang, yung 3M, minultiply mo sa 2 para makuha mo yung 6. And then, ganun din sa calcium hydroxide na merong molarity na 1, para makuha mo yung kanyang normality, so, i-multiply mo lang yung 1 sa 2, you will get 2 as a normality. Yan. Okay? So, now let's have some sample problems here. So, we have this problem. How many grams of potassium dichromate are required to prepare 125 ml solution whose concentration is 1.83 m. Okay, so gamit po yung formula ng molarity, so which is equivalent to the mole of solute or the potassium dichromate here divided by the liter of solution. So, ang gagawin natin para makuha natin yung mass, so given the molarity of 1.83 and the liter of solution magiging 0.125 kasi you have 125 ml. So although pwede mo naman din siyang gawing in terms of scientific notation. Okay, ngayon i-express natin yung mole as a mass divided by 294.2 since the mole is equivalent to mass divided by the molar mass. Ngayon, speaking of molar mass, alamin natin yung molar mass ng potassium dichromate. So, that will be 294.2 grams per mole. And then, salt, no? Parang ang mangyayari na lang po dito is multiply na lang po lahat ng mga quantities. So, we have 1.83 being multiplied by 0.125 being multiplied to 294.2. So, you will get 67.298 grams. No? Yan. Next problem. So, determine the mole fractions of both substances in a given solution containing 36 grams of water and 46 grams of glycerin. So, we have this chemical formula for the glycerin. So, alamin na natin yung kanyang molar mass o yung molar mass ng bawat isa. Para sa water, we have 18.016 grams per mole. At para sa glycerin, meron po siyang 92.094 grams per mole. So, ngayon, para makuha natin yung kanilang mole fraction, alamin natin ang kanilang mga moles. So, let's say yung A, yun yung sa water, B, doon sa glycerin. So, kunin natin ang number of moles ng bawat isa. Para sa water, yung 36, divide lang natin sa 18.016. So, you will have 1.9982. At para naman sa glycerin, yung 46, i-divide lang po sa 92.094. So, you will get 0.4995. And then, para makuha yung mole fraction muna ng water, so, i-divide lang po yung kanyang mole na 1.99 doon sa sum ng dalawang moles na nakuha natin. And you will obtain 0.8. And then, ganun din ang gagawin mo para sa B. So, ilagay mo dito yung 0.4995 at makukuha mo yung 0.2. Although, pwede naman din sa pamamagitan lang po ng 1 minus 0.2. No? But of course, you have to check carefully. No? Kasi kahit nasabihin natin na pag pinagsama mo naman yung dalawang mole fraction na yan, equal sa 1, kung mali naman yung naging procedure or calculation din. Okay? So, ngayon, punta naman tayo sa number 17 problem. Example number 17. So we have the density of a 2.45 m. So basically, this is a molarity. Aqueous solution of methanol having this chemical formula is 0.976 grams per ml. What will be the molality of the solution? Ayan. So ano daw yung kanyang magiging molality? So para makuha yung kanyang molality, kailangan mo lang makuha muna yung mole solute divide sa kilogram solvent. Okay. Ngayon, dito kasi sa ating problem, ang mangyayari kasi para makuha natin yung mole of solute, magdedepende tayo sa molarity. So basically, the molarity is equal to the mole solute per liter of solution. Okay. At dahil wala pong binanggit kung ilang liters of solution, we will assume 1 liter. Why that? No, mag-assume po tayo ng 1 liter. So, pwede po bang kahit ano? Pwede naman. No? Kasi ang mangyayari naman dito, kahit anong amount or kahit ilang liters ng solution ang gagamitin natin, maka-cancel out po yan. It is because meron pa tayong paggagamitan ng liters of solution, which is later on i-discuss natin. So, pero doon muna tayo sa may mole solute na galing po sa molarity. So, ngayon, using the 1 liter solution, so you will obtain 2.45 moles of solute or the methanol. Okay, yung methanol kasi natin dito ang solute. Then, para makuha si kilogram solvent, so, using the density of solution, which is 0.976 grams per ml, so ang gagawin natin, you are going to use the formula of density. So, dito, ang ginawa natin, para makuha natin yung mass ng solution, i-multiply lang natin yung density ng solution sa volume ng solution. So, ito yung isa pang calculation natin na gagamitan natin ng liter of solution na inassume natin na 1 liter. And using the density, 0.976 grams per ml, ang magiging mass ng solution is 976 grams. Ngayon, syempre, ang kailangan kasi natin is yung mass ng solvent. So, ibabawas natin dito sa mass ng solution yung mass ng solute para makuha natin yung mass ng solvent. So, what next to do is, para makuha si mass ng solute, gamit yung mole ng solute, i-multiply lang natin sa molar mass ng solute o yung molar mass ng methanol. So, ito po yung molar mass ng methanol. So, 32.042 na minultiply sa 2.45 para makuha po yung 78.5 grams ng methanol na meron dito sa solution. At ibabawas na lang to sa 976 grams na mangyayari, ang magiging solvent natin is around 0.8975 kilograms. Yan. And then from that, dahil nakuha na naman natin yung mole ng solute at kilogram ng solvent, so you will have 2.45 mole divided by the 0.8975 kilograms, and you will get 2.7298 molal or mole per kilogram. Okay. Next one. So, we are going to calculate naman dito yung molar concentration or the molarity of a sulfuric acid solution of density 1.198 grams per cubic centimeter containing 27% of sulfuric acid. Okay. So, ngayon, dito, alamin daw natin yung molarity galing dun sa solution na given yung density at given itong 27% na siyang magiging percent weight or percent mass ng solute. Kasi ang solute natin dito is yung sulfuric acid. So, of course, para makuha si molarity, kailangan malaman muna natin yung mole ng sulfuric acid na i-divide naman sa magiging liters of solution natin. Okay. So, ang gagawin natin, kunin natin yung mole ng sulfuric acid. So, pero bago yan, kailangan makuha muna natin yung mass ng sulfuric acid na gagamitin. And for this, we are going to assume, again, 1 liter of solution. So, mag-assume tayo ulit dito, just like yung naging analysis natin kanina. And then, yung sinasabing 27% na mass, so actually, it represents that for every 100 grams of solution, there will be 27 grams of solute or the sulfuric acid. And from that, kukunin na natin yung mass ng sulfuric acid by multiplying the density by the volume. So, kumbaga parang ang una mo munang gagawin, kunin muna natin yung mass ng solution. Kunin muna natin yung mass ng solution sa pamamagitan po ng mag-multiply ng 1.198 grams per cubic centimeter sa 1,000 cubic centimeter. So, saan to nanggaling itong 1,000 cubic centimeter? Yan po ay hango sa conversion ng liter to cubic centimeter. Kasi 1 liter is equivalent to 1,000 milliliter or 1,000 cubic centimeter. Okay? And from that, ayan, makukuha natin dito yung mass ng solution. However, pwede na po natin idiretso yung pagkuha po ng mass ng solute by using the percentage mass. So, gamit yung itong ginamit nating conversion factor dito na 27 grams of sulfuric acid per 100 grams of solution, so you will obtain 323.46 grams of sulfuric acid. So, ito po yung totoong mass ng sulfuric acid na ginamit. And from that, alamin natin yung moles ng solute, which is magagawa lang natin yan pag dinivide yung 323.46 grams sa 98.086 grams per mole. Ayan. And then, makukuha na natin yung magiging moles ng solute na 3.2977 mole. At dahil, yung ating liter of solution naman is 1, so pag dinivide mo tong mole sa 1, so makukuha mo pa rin ay 3.2977 bilang molarity. So, ayan po yan. Ngayon naman, let's go to the dilution. Ayan. So, ano naman ang meron dito sa dilution? Basically, ang ginagawa po dito is preparing a less concentrated solution from a more concentrated solution. So, let's say, meron kang mataas na concentration na meron dun sa solution. So, for you to decrease the concentration, so what you are going to do is to add solvent. So, magdadagdag ka ng solvent provided that the solute is constant pa rin. So, yun pa rin. So, hindi naman magbabago yung solute. Okay? So, for this one, we are going to establish this relationship. That is, the mole of solute is being constant before and after the dilution process. Okay? And of course, using the concept of molarity, so, which is equivalent yan sa mole of solute divided by the liter of solution. So, i-multiply lang natin yung molarity sa liters of solution para makuha natin yung mole ng solute. And for this, we are going to establish this equation. That is the initial molarity multiplied by the initial volume of solution is equivalent to the final molarity multiplied by the final volume of the solution. Okay? Kung gusto natin malaman kung ilang o gaano karaming amount ng solvent ang gusto mong idagdag for you to achieve the less concentrated solution. So, kunin mo lang naman yung difference ng final at initial volume ng solution. Ayan. So, let's have this example number 19. Okay. So, describe how would you prepare 250 ml of a 2.25 m sulfuric acid solution. So, we have this molarity of 2.25 m of 250 ml. Starting with the 7.41 m molar concentration of stock solution of sulfuric acid. So, dito, initially, meron kang 7.41 m ng sulfuric acid solution. So, ang kailangan mo dito malaman is kung ilang ml initially meron ang solution before you achieve this 250 ml of 2.25 m sulfuric acid. So, what we are going to do is this, gamit yung ating equation. So, initial molarity is 7.41 while the initial volume is said to be unknown. Then, the final molarity and the final volume would be this one, 2.25 multiplied by 250. So, you will get an initial volume of 75.91 ml, which means, starting from 75.91 ml, para ma-achieve po yung 250 ml, so ibawas lang natin, you will get 174 ml of solvent. So, you need to add 174 ml of solvent para ma-reach mo yung less concentration level na 2.25 ml. So, punta naman po tayo ngayon sa solution stoichiometry. So, dito po ay i-involve na po natin yung mga masses, volume, moles, when it comes to the calculations in the solution. So, we have this one, no? We have this gravimetric analysis. So, dito, ang sabi dito, it is a technique based on the measurement of mass, which involves the formation, isolation, and mass determination of a precipitate, no? So, dito, ang ginagawa dito, basically, if you have a certain substance, let's say you have an initial substance, and you are going to mix that with water and another substance, as you can see here. Ayan. So, meron po tayo ditong dalawang substance that will undergo, okay, the reaction, and at the same time they are going to tawag dito, uh, dissolve in water, no? So kumbaga ginagawa dito, ayan, so papatunawin muna yung isang substance dito sa water, then magdadagdag po ng another substance in order to determine kung ano po yung magiging mass ng precipitate. Basically, itong precipitate na to, this is the insoluble substance na mabubuo after pagsamahin yung mga reactants. Yan, when it comes to the chemical reaction. So, yun po ang kailangan natin ditong malaman. No? So, kapag na-identify na natin kung gaano po kabigat ang precipitate, pwede na po natin malaman kung gaano din kabigat yung mga original na mga reactants na ginamit, okay, initially. No? Pag sinabi natin precipitate, basically it is the insoluble part of the chemical reaction. Ayan. So, usually, ang mga insoluble na to is tawag dito, kapag po pinagsama yung mga soluble salts. Ayan. So, sabi nga dyan, when you say precipitation reaction, it refers to the formation of an insoluble product, salt. No? So, yan yung nasa product side, which is mixed by the soluble salts in order to form this insoluble particle or insoluble substance na precipitate. So, kung naalala nyo, dun sa ating double replacement reaction, na kung saan, in order for you to have that reaction, is kailangan, pagsamahin mo yung mga soluble na mga reactants, and then, ang magiging product po dapat is, there should be at least, there should be a one insoluble and one soluble na mga products. Ayan. So, dito kung mapapansin nyo, after natin pagsamahin yung mga soluble salts, so meron po tayo dito ayan, itong mga namumuo na to, so these are the insoluble or the precipitate. Okay? And then, itong mga medyo liquid, so yan naman po yung mga soluble, mga salts. Ayan. So now, balikan lang natin, syempre yung mga solubility rules. Kaya lang kasi doon kasi, ano yun kasi, in terms of reaction. Kasi dito, these are the solubility rules applied to the common ionic compounds in water at a certain temperature of 25 degrees Celsius. So, pagdating po sa solubility, i-consider din kasi natin yung specific na temperature. So, dito, this is at least at 25 degrees Celsius. So, of course, syempre, yung solution naman is nakaka-apekto din naman yung temperature, di ba? Pag malamig or mainit. Okay. So, soluble compounds, so these are the compounds that can be, that is soluble in water. So, that are soluble in water. So, such as itong mga compounds na may mga alkali metal ions, kagaya ng lithium, sodium, potassium, rubidium, cesium, kasama na rin yung ammonium. Then, yung mga nitrates, bicarbonates and chlorates, halides, and sulfates. Kaya lang, hindi po lahat ng halides at sulfates ay mga soluble. No? So, ito yung mga insoluble naman. Okay? And then, pagdating naman dito, mga insoluble naman, syempre kasama din sa mga insoluble, yung mga carbonates, phosphates, chromates, sulfides, at hydroxides. Pero, pwede silang maging soluble kapag may kasama silang alkali metal ions. Ayan. So, yan po yan. Okay. Now, let's have this ionic equation. So, ano ba yung pag sinabi nating ionic equation? Basically, it is an equation in which it shows the dissolved ions of the compounds involved in the chemical reaction. So, ang gagawin natin, pagdating po sa ionic equation, halimbawa, meron kang isang chemical equation that is already balanced, and you are going to dissolve that in terms of ions, yung mga soluble. So, yung mga soluble na mga salts, paghihiwalayin natin yan in terms of ions. While yung insoluble, we will just retain that. Okay? Ngayon, kapag yun, nakabuo ka na nga ng ionic equation, so titignan mo naman yung mga tinatawag ng mga spectator ion. So, ano naman yung mga spectator ions? So, actually, these are the ions that are not part of the chemical reaction. So, hindi talaga sila kasama talaga. So, that's why, dito sa mga spectator ions, no, sa ionic equation, they will be cancel out. So, i-cancel out lang natin, and then yung matitira, yun naman po ang bubuo sa tinatawag nating net ionic equation. So, dito ang sabi niya, it shows only those elements, compounds, and ions that are directly involved in the reaction. So, yun pala, no? So, may mga ions or elements or compounds na hindi pala pwede maging part ng chemical reaction, although na-represent siya doon sa chemical equation. Okay? So now, let's have some sample problems here. So we have this example number 20. So we have 0.7077 grams of an ionic compound containing chlorine ions and an unknown metal being dissolved in water. So hindi natin alam kung ano tong ionic compound na to, basta ang sinabi niya lang, given na yung kanyang yung anion is yung chlorine. Then yung cation, hindi ko na-identify. Pero meron po siyang mass that is being dissolved in water and treated an excess of silver nitrate. And so, paano lumalabas na itong silver nitrate, siya yung excess reactant or excess reagent, while itong ionic compound na unknown is yun yung siya ang magiging limiting reagent natin. So now, if 1.3602 grams of silver chloride, so basically this silver chloride is the precipitate or the insoluble salt, what will be the percent by mass of chlorine in the original compound? So ngayon, para malaman natin kung ano ba magiging percentage ng mass ng chlorine doon sa ionic compound na hindi natin alam. So what we are going to do is to determine first the mass of chlorine using the mass of the precipitate. So gamit yung mass ng precipitate, so we have 1.3602 grams of silver chloride. Okay? Then, ang gagawin muna natin is i-convert muna itong grams ng silver chloride sa moles. So, mamamagitan po ng pag-divide sa 1.3602 sa 143.3 grams per mole na molar mass ng silver chloride. Then, after that, by dimensional analysis, so, for every 1 mole of silver chloride, there will be a 1 mole of chlorine. And i-multiply na natin yan finally sa 35.45 grams of chlorine, which is the molar mass naman ng chlorine. So, dapat nagigay pala ako dito ng per mole. Per mole. So, per mole of chlorine. Yan. And you will get 0.364 grams of chlorine. And from this one, so malalaman na po natin kung ano po ang magiging percentage mass ng chlorine. So, kung titignan natin, no, bakit kinuha natin yung mass ng chlorine doon sa mass ng product? Because the silver chloride, although that is a product, pero namumuo naman dyan. So, it is in a solid form na pwede naman natin maging basehan para makuha naman natin yung mass ng mga reactants. Okay? Kaya lang, kasi dito, dahil ito nga yung limiting reagent, no, itong ionic compound, kaya madali lang po natin siya nakuha agad. And then, i-divide na lang natin yan sa mass ng ionic compound na 0.7077, and you will get 47.53% ng chlorine ang meron dun sa original na ionic compound. Okay? And from that, pwede mo naman din malaman, no, malalaman mo naman din kung ano magiging pinaka-unknown talaga na ionic compound. So, siguro magdagdag pa tayo ng iba pa mga given like yung pwede yung chemical equation. So, something like that, no? Okay. O yung siguro yung isa pang product, diba? So, kung nabanggit sana yung isa pang product, baka malalaman din natin kung ano yung unknown metal. Okay. So, now let's go to the next problem. So, ito naman, let's do how we are going to formulate a net ionic equation. So here, we have what happens or predict what happens when an aqueous solution of lead 2 nitrate is added to an aqueous solution of potassium iodide. So dito, meron po tayong lead 2 nitrate. Ibig sabihin po niyan, ang magiging chemical formula niyan is this. This is the chemical formula of lead 2 nitrate. Ibig sabihin niyan, ang lead ay may charge na positive 2, kaya siya lead 2. And then nitrate, negative 1. Then para naman sa potassium iodide, this will be Ki. Then having the products of lead 2 iodide and potassium nitrate. So yung lead 2 iodide, siya ang magiging insoluble. And then after that, balance po natin yung equation. So maglagay lang tayo dito ng 2. Ayan, dito sa may potassium iodide at dito sa may potassium nitrate. Then, i-separate na po natin into ions yung mga soluble na salts. So, yung mga soluble lang po ay, gaya na sinabi natin kanina, yung mga insoluble, hindi po natin i-dissolve into ions. Kasi nga, insoluble sila. Okay? So, yung lead, may charge kang positive 2. While yung dito sa may nitrate naman, so yung subscript na 2, gagawin natin siya ditong coefficient. Then, dito sa may potassium iodide, dahil may 2, so lalagyan natin ng parehas na 2, yung potassium ion at yung iodine ion. And then, ganun din sa may potassium nitrate. Ayan. Then, ang mga spectator ions po dyan ay itong potassium ion at ang nitrate ion. Dahil parehas po silang meron sa magkabilang side ng equation, so they will be cancelled out. And then, ang matitira na lang po, yung lead ion at yung iodine ion being multiplied by 2, resulting to the lead 2 iodide. So, which will comprises the net ionic equation of this chemical reaction. So, yun pala, no? Ang mga involved lang pala dito sa ating chemical reaction pala ay yung lead at saka yung iodine lang pala. No? So, yan po. Now, let's go to this example number 22. So, if 30 ml of 0.150 m of calcium chloride is added to 15 ml of 0.1 m of silver nitrate, what will be the mass in grams of the precipitate? Okay. So, dito, given po yung mga parameters po ng reactants. So, which are the calcium chloride and the silver nitrate. So, ang gagawin naman next natin dito is to formulate the chemical equation which will be the calcium nitrate and the silver chloride as the products. No? Yan. So, sila po yung magiging products natin na kung saan itong silver chloride, siya yung magiging insoluble. Yan. Siya po yung magiging insoluble natin dito. So, dito natin malalaman kung ilang grams meron dapat ito. Kung given itong mga parameters nga po ng given itong mga nasa reactant side. Okay. So, what we are going to do is, para malaman natin, kasi dalawang reactant yan eh. So, what we are going to do is to do the stoichiometry calculation using each of them. So, kumbaga, aalamin natin yung magiging mass ng silver chloride using the calcium chloride at another calculation naman using the silver nitrate. And for that, dito napapasok yung concept ng limiting reagent. Okay? So, dito guys, pwede naman, pwede nyo munang gawin is identify nyo muna sino yung magiging limiting reagent base sa magiging number of moles ng silver chloride. And then after that, pag nalaman mo na kung sino yung limiting reagent, pwede mo na ma-identify yung mass. Or pwedeng, i-diretso mo na yung pagkuha ng mass ng silver chloride using this solution na ito, using this calculation. So, mula doon sa calcium chloride, having 30 ml, so, i-multiply natin siya dun sa kanyang molarity. No? So, mapapansin naman natin, we have this 0.150 m equivalent to 0.150 mole of calcium chloride divided by 1,000 ml. So, ginawa ko siyang ml para madali siyang ma-multiply sa 30 ml. And then, in terms of relationship between the stoichiometry coefficient, so there will be 2 moles of silver chloride per 1 mole of calcium chloride. Yan. Then, multiply na natin sa magiging molar mass ng silver chloride. So, you will obtain 1.2897 grams. And then, para naman sa silver nitrate, gamit yung 15 ml, so, multiply natin sa 0.1 na molarity. So, again, ayan, should be mole pala dapat. So, dapat ito ay mole. mole of silver nitrate per 1,000 ml of solution. Then, using again the stoichiometry coefficient between silver chloride and the silver nitrate, so importante po na dapat tama yung equation, dapat balance. So, para tama ka dito sa calculation na to. Then again, multiply mo yan sa 143.3 grams of silver chloride. So, you will obtain 0.21495 grams. So, dito, paano ba natin malalaman kung sino ang pipiliin nating final answer? Siyempre, dun tayo sa mas mababang amount ng product na nakuha na yun nga yung definition natin ng limiting reagent. That's why we're going to consider 0.21495 grams of silver chloride as our final answer. Yan. Kasi kung ito yung i-consider natin, medyo sosobra yung sa or medyo kakapusin. Yan. So, medyo kakapusin itong pag ito yung ginawa nating limiting reagent, so yung silver nitrate ay hindi siya susobra. So that's why itong calcium chloride, siya po ang magiging excess, while yung silver nitrate is yung magiging limiting reagent. Again, when you say limiting reagent, it is the one that produce small amount of mole or small amount of number of mole or small amount of product. So we will now go to the acids and bases. No? So basically, these acids and bases are the compounds, okay, in which they dissociate. No? So these are compound that dissociates in water to yield the ions that we're going to need here. No? So let's have the acid. No? One of the most popular definition of acid is it is any compound that dissociates in water to yield hydrogen ion. And mostly ng mga acids, no, na pagdating sa chemical formula is lagi siyang may H na kasama or hydrogen ion na kasama. So ngayon, meron po tayong classification pagdating sa mga acids. We have the strong acids and the weak acids. So ano ba yung pag sinabi nating strong acids? So basically, these are the acids that dissociates, no, or napaghihiwalay niya yung acid into ions completely kapag siya ay hinalo sa tubig. So for example, itong mga hydrochloric acid, hydrobromic acid, hydroiodic acid, nitric acid, sulfuric acid, and perchloric acid. So those are some strong acids. While ito namang weak acids, so they cannot or they do not dissociate completely or hindi nila napaghihiwalay yung acid into ions completely kapag hinalo sa tubig. So these are the hydrofluoric acid, phosphoric acid, and the acetic acid. Yan. So hindi madali silang mapaghiwalay o hindi natin kaagad madaling makuha completely yung dissociation na sinasabi. Now, paano ba natin masasabi na ito ay acid? So bukod sa meron siyang hydrogen ion. So una, acids conduct electricity in aqueous solution. Yeah. So, since nasa-separate na natin siya into ions, basically, we have the hydrogen ion. Acids have sour taste. So, medyo may pagka-maasim. Yan. So, for example, yung mga juice, vinegar. Yan. Then, acids turn blue litmus paper to red. Kapag, let's say, pinagsama mo yung blue litmus paper or hinaluan ng acid, yung blue litmus paper, nagiging red siya. pH value niya, so mamaya i-discuss natin yung pH na yan, between 0 and 7. Acids neutralize bases. So kapag, yung nabanggit natin last time, di ba, yung neutralization, kapag nag-react yung acid at base, so their product will be salt and water. And acids react with active metals to form hydrogen. So, ayan po yan nangyayari sa mga acids. Ayan. So, usually yung mga acidic, like yung, syempre, yung sa stomach, diba? Kaya nagkaka-acid ang tao. Ayan. Juices, ayan, like yung mga calamansi, lemon, ayan, ano pa ba yung mga acidic. So, syempre, yung mga vinegar na sinabi na natin kanina. Okay. So, ngayon, kung ang acid ay any compound that dissociates in water kapag siya ay hinalo to have an hydrogen ion. Ang base naman, ang kailangan niyang ion is the hydroxide ion or OH having a charge of -1. So yan po ang isa sa mga popular na definition niya. Then, meron din siyang classification, so the strong and the weak bases. So, pag sinabi nating strong base, syempre, hindi naman, syempre, it is any base that completely dissociates into ions when it dissolves in water. So, madaling mapaghiwalay into ions like itong sodium hydroxide, potassium hydroxide, calcium hydroxide, and strontium hydroxide, barium hydroxide, so yung mga alkaline at saka alkali. Yan. So, yan yung isa sa mga strong bases. While weak bases, kagaya po ng ammonia. Okay. So, now, here are the properties of base. So, of course, bases can conduct also electricity. Then, meron siyang hydroxide ion. Bases have a bitter taste. Medyo mapait, like yung mga sabon, coffee. Kabilang yan sila sa mga bases. Then, it turns red litmus paper into blue. So, kung yung acid, di ba, from blue to red. Then, bases have a pH level between 7 and 14. And, of course, just like yung nabanggit kanina, kapag siya ay hinalo sa acid, it will form salt and water. Okay. Yung sinasabi natin kanina na yung pH level. Yan. So, ano ba yung pag sinabi natin pH or the power of hydrogen na sinasabi? So, yun po pag sinabi natin pH. No? It measures the acidity of a substance, and it is used to determine the concentration of the hydrogen or hydroxide ions of a given substance. No? So, dito natin nalalaman yan. Kung gaano ba ka-concentrate yung hydrogen o yung hydroxide ion na meron sa acid or base respectively. And then, ayan, meron pa tayong power of hydrogen. Then, isa naman, ito namang isa, syempre, this is POH, this is the power of hydroxide. So, basically, syempre, alam naman natin na kanina, nabanggit naman kanina sa acid, it is between 0 to 7, while yung base naman is 7 to 14. Yung 7 naman na pH level is, of course, this is the neutral value, which is usually sa mga water po yan. Okay, pH level ng water. Okay, so ngayon, para malaman natin kung ano ba magiging pH level or power of hydroxide na meron ang bawat acid or base. So, we can have this one, no? Negative log of H+. And for POH, negative log of OH. So, ano ba yung mga yan? So, itong mga to, this represents as this is the hydrogen. Of course, this is the hydrogen concentration. Yan. Okay? In terms of what? Moles per liter. And ganun din to. So, syempre, ito yung hydroxide ion concentration. Ayan. So, in short, molarity. Ayan, molarity, molar concentration po ng hydrogen ion or ng hydroxide ion. And then the relationship between the pH and the POH, so kapag pinagsama, so it will be equivalent to 14. Ayan. So, kaya madali lang pong malaman yung pH level or POH level ng isang acid or ng base. Then let's go to this one. We have this what we call the acid-base titration. So ito, ginagamit natin to para malaman po yung concentration po ng acid or ng base. Usually, base eh. So usually yun ang, yung acid pala, sorry. Yung acid pala, yan. So usually, ang hinahanap dito is yung concentration ng acid. So given po yung concentration ng base, no? Then yung amount ng acid at saka ng base. So dito, we have this what we call the titration. So dito, ang ginagawa po dito, yung acid na nandito sa loob nitong tube na ito, having a given amount, no? So given na yung kanyang, tawag dito, yung, tawag dito, yung volume ng acid. And then yung itong base, no? Let's say we have the sodium hydroxide na siyang magiging standard solution, ilalagay po siya dito sa burette. Yan, burette. Yan. Having, let's say, meron siyang initial volume reading. Yan. And then, meron din yan na given na concentration. Itong base na ito na nandito. And then, paano ba natin malalaman kung ano yung magiging concentration level ng acid? Well, kapag halimbawa, ang ginawa natin is nilagyan ng base, itong acid na to. Then, kapag po na-reach niya yung tinatawag na neutralized solution, or kapag na-reach na niya yung color pink, no? So, that's the time na i-stop mo na yung buray. Then, alamin mo kung ano ang kanya magiging final volume reading. And then, yung difference sa pagitan po ng initial at ng final volume readings, dyan natin malalaman kung ilang ml po ng base ang nilagay mo sa given amount ng acid para malaman natin yung magiging concentration level nga ng acid. So, ayan. So, kapag nalaman na natin yung volume na-identify natin yung volume nung unknown solution at saka nung standard solution na nandito sa burette na to. Ayan. So, madali na natin malalaman kung ano ang magiging concentration ng unknown solution given na rin yung sa standard solution. So, ulitin ko lang po, yung standard solution natin, yung base na nakalagay dito sa burette, tapos ito namang acid, no, yung unknown solution na nakalagay dito sa tube or sa okay. So now, let's have some problem here. Okay. So example number 23. So we are going to calculate the concentration in molarity. So alamin natin ang concentration level ng sodium hydroxide, which is the base. Ayan. Solution, if 25 ml of the solution are needed to neutralize 17.4 ml of a 3.312 m or molar concentration of hydrochloric acid solution. Yan. So, dito alamin natin yung magiging concentration ng base. So, para malaman natin yan, ang una mong gagawin is to formulate an equation. So, dahil dito, ang involved dito ay hydrochloric acid at sodium hydroxide. So, para makabuo po ng, sabi nga natin kanina, di ba, salt. So, we have NaCl and water. So, check lang natin kung balance na ba siya. Okay, balance naman na. Okay. Then, from that, using again, yung ginagawa nating calculation, so, given po yung 17.4 ml na, at saka yung 0.312 m doon sa acid, so, what we are going to do is, alamin natin yung magiging mole. Yan. Alamin natin ang magiging mole ng sodium hydroxide. Sa mamagitan po nung given sa acid. So, para malaman natin yan, so, ang gagawin natin is, yung 17.4 ml, i-multiply natin yan sa 0.312 mole ng hydrochloric acid per 1,000 ml solution. Yan. Kasi diba, molarity is mole per liter. Kaya lang ito, yung 1 liter, ginawa ko lang siyang 1,000 ml. So, yun po muna ang unang mong gagawin, guys, no? Kunin mo muna yung mole ng acid. Okay. Next thing to do is, to use the relationship between the hydrochloric acid and the sodium hydroxide. So, as you can see, wala namang pong number na nakamultiply dyan. So, we can say that 1 mole of sodium hydroxide per 1 mole of hydrochloric acid. And from that, malalaman na natin kung ano magiging moles ng sodium hydroxide, which is around, pag natin yan. So, we can have 5.2488 times 10 raised to negative 3. So, yan po ang magiging mole ng base natin. And from that, alamin na natin yung magiging molarity. So, we can have yung 5.2488 times 10 raised to negative 3 moles ng sodium hydroxide divided by kung ilang liters meron yung base. So, we can have 25 ml. So, make it, gawin ko muna siyang scientific notation. And 25 times 10 raised to negative 3. And from that, malalaman na natin kung anong molarity. So, we can have 0.2172. Yan. Moles per liter of sodium hydroxide solution. So, ganun lang naman po, guys, no? Para makuha natin yung concentration, whether it is a base or acid. No? Yan. So, kung gusto mo malaman kung ano ang kanyang pH level, well, negative log lang naman, di ba? Kaso ano nga lang, in terms of compound kasi. Pero ang kailangan kasi natin is yung hydrogen or hydroxide level concentration. Okay, anyway, let's go to number 24. Yan. How many ml of 0.836 molar concentration of sodium hydroxide solution are needed to neutralize 25 ml of 0.355 molar concentration of sulfuric acid solution? So, again, gawa tayo ng equation. Yan. So, just like yung ginawa natin kanina. Okay, so, gawin natin, sulfuric acid, dagdagan mo daw ng, or pagsamahin natin yung sulfuric acid at sodium hydroxide. So, you will have sodium sulfate. Yan. Sodium sulfate plus water. At let's do the balancing. Dalawa dito, tatlo. OH. So, maglagay tayo siguro dito ng dalawang dito. Maglagay tayo dito ng 2 kasi dito dalawa siya. Then, magiging 6 na, no? Or, sorry, dalawa plus dalawa, 4. So, maglagay ako dito ng 2. Yan. So, balance na po siya. And from that, no, alamin naman natin muna, no, dahil given po or kompleto na yung sa acid part eh. So, kunin natin yung mole ng sodium hydroxide. Just like yung ginawa lang natin kanina, no? So, yung 25 ml, i-multiply mo siya sa molarity niya. So, let's make it 0.355 moles of sodium hydroxide per 1,000 milliliter of solution. Then, multiply lang natin yan sa ano bang ratio ng sodium hydroxide at ng sulfuric acid. So, sorry, dapat ito pala ay sulfuric acid pala. Sorry. Dapat ito pala ay sulfuric acid. Sulfuric acid pala dapat. So, H2SO4, then 1 mole of sulfuric acid per 2 moles of sodium hydroxide. So, for this one, ano ba makukuha nating number of moles ng sodium hydroxide? So you will get 0.0 and 0.01775 moles of sodium hydroxide. And using the formula of polarity, pwede na natin malaman kung ilang liters of solution ang meron dito sa base na ito. Yan. So, what we're going to do, yan, 0.836, then equals yung mole. Yan. So, alamin natin ang liters of solution. Yan. And then from that, makukuha na natin is what? Ano ba makukuha natin? Divide mo lang sa 0.836 yan. No? So, you will get yan. Ginawa ko lang po siyang ml na lang. So, para maging 21.23 milliliter of sodium hydroxide solution. Yan. Okay? So, ayan po yan. O, dapat ginawa ko na lang itong volume. So, gawin ko na lang siyang volume. Volume. Yan. And volume of the solution or volume of the sodium hydroxide solution is 21.23 ml. And let's have the next item. So here, madali na lang to kasi pH level lang po ang tanong or yung concentration ng hydrogen ion. So, pH of rainwater in a certain region of the northeastern United States at a particular day is or was 5.23. So, calculate the hydrogen ion concentration of the rainwater. So, base dun sa formula natin na pH equals sa negative log of the concentration of the hydrogen ion. So, para makuha natin yung concentration na yan, so, ang magiging equation natin, since log yan, having a base of 10, so pwede natin siyang gawing 10 raised to negative of kung anong value ng pH. So dito ang lalabas 10 raised to negative 5.23 at ang kanyang magiging concentration ng hydrogen ion ay negative 5.23. So you will have 5.888 times 10 raised to negative 6, so molar per liter. So yan po ang magiging molar concentration ng hydrogen ion dyan sa rainwater na yan. Okay, and for the next, or for our last problem, so in a sodium hydroxide solution, okay, the concentration is 7.2 times 10 raised to negative 5 m. So, yung concentration po ng hydroxide ion is 7.2 times 10 raised to negative 5 mole per liter. So, ngayon, alamin natin yung kanyang pH solution. So, take note, pH po yung kailangan malaman. So, bago natin makuha yung pH, alamin muna natin ang power of the hydroxide. So, negative log of the concentration of the hydroxide. So, we can have negative log of, yan. So, kunin mo lang yung negative log of 7.2 times 10 raised to negative 5. Okay. So, ano makukuha natin? So, makukuha natin is 4.143. Yan. So, that is the power of the hydroxide. Pero kailangan natin malaman is yung pH level. So, para makuha natin ang pH, 14 minus the power of the hydroxide. So, we can have 14 minus 4.143. And minus lang natin yan. We can have 9.857. So, ayan. So, that is how we are going to analyze po yung mga iba't ibang calculations and some methods in relation nga po doon sa properties and composition na meron po sa mga iba't ibang klase ng solution. And that's it for today. And if you have any questions, so just message me. And hopefully na marami po tayong naintindihan for this lecture. So, thank you for watching, guys.